Have you ever wondered how AI can learn to play games better than humans, or how self-driving cars learn to navigate traffic? Today, we're going to explore the magic behind these phenomena, the world of reinforcement learning. Reinforcement learning is a unique type of machine learning, a branch of artificial intelligence that's all about decision-making. It's like a virtual trial-and-error process, where an agent, let's say a robot, interacts with its environment, learning from its actions, and improving its performance over time. Imagine this. Our robot agent is placed in a maze. It doesn't know where it is or how to get to the end. However, it's not completely in the dark. Each action it takes, every move it makes brings about a reward or a penalty. Maybe it bumps into a wall, that's a penalty. Or perhaps it discovers a shortcut, that's a reward. Over time, it begins to understand the consequences of its actions and adjusts its behavior accordingly. This is the heart of reinforcement learning, an agent learning to make optimal decisions based on the rewards and penalties it receives. It's a learning method that's all about interaction and adaptation. It's not just about learning to navigate a maze, it's about learning how to adapt to new mazes, new challenges, and even new environments. And it's not just robots and mazes either. Reinforcement learning can be applied in a myriad of settings, from teaching AI to play complex video games, to programming self-driving cars, to optimizing energy consumption in smart homes. The possibilities are virtually limitless. The crux of reinforcement learning lies in this. It's not about programming an agent with pre-existing knowledge or rules. It's about letting the agent learn from its own experiences, from its own mistakes and successes. It's about teaching the agent to understand the consequences of its actions and to adjust its behavior to maximize its rewards. So in essence, reinforcement learning is about learning from the consequences of our actions. So how does reinforcement learning work in practice? Let's break it down. The first key component of reinforcement learning is the agent. This is typically a computer program or algorithm that's learning how to navigate a particular problem or environment. The agent makes decisions, takes actions, and learns from the outcomes. Next, we have the environment. This is the context in which the agent operates. It could be a virtual landscape for a video game character, a financial market for a trading algorithm, or even the real world for a self-driving car. The agent interacts with the environment by taking actions. Each action has consequences. The environment responds to the agent's action by presenting a new state. This state is simply a snapshot of the environment after the action has been taken. It's like the next frame in a movie after the actor has delivered their line. And here's where things get interesting. Along with the new state, the environment also gives the agent a reward. Now, this isn't a gold star or a pat on the back. It's a number. This number could be positive, indicating the action was beneficial, or negative, indicating the action was detrimental. The reward is crucial because it provides the feedback the agent needs to learn. Imagine you're playing a game of chess. If you make a move that puts your opponent in checkmate, you'd receive a positive reward. If your move results in your king being checkmated, you'd receive a negative reward. You use this feedback to inform your future moves, trying to maximize your positive rewards. And this is exactly what the agent does. The agent uses this feedback to update its knowledge or its policy. A policy is simply the strategy that the agent follows when deciding what action to take in a given state. It's the agent's game plan, if you will. By interacting with the environment, receiving feedback and updating its policy, the agent gradually learns the best actions to take in each state. Therefore, the goal of the agent is to learn the best actions to take in each state so as to maximize its total reward over time. Now that we know the basics, how does an agent learn the best decisions to make? In reinforcement learning, the learning process is a delicate dance between exploration and exploitation. So, what are these two? Exploration, as the term suggests, is the act of an agent probing the unknown, trying out new actions that it hasn't taken before. It's akin to venturing into uncharted territories on a map. On the other hand, exploitation is when an agent uses what it already knows. It takes actions that have proven to yield good rewards in the past, much like returning to a well when you know there's water. But here's the catch. If an agent spends all its time exploring, it may never reap the rewards of the knowledge it's gathering. Too much exploration can lead to missing out on known opportunities. Conversely, if an agent only exploits what it already knows, it may never discover potentially better alternatives. Too much exploitation can lead to a stagnation in learning. The agent needs to strike a balance, a sweet spot between exploration and exploitation. Now you might be wondering, How does an agent decide when to explore and when to exploit? This is where the concept of a policy comes into play. A policy is essentially a strategy that guides the agent's actions. It's a blueprint that helps the agent decide whether to explore or exploit based on its current knowledge and the situation it finds itself in. Policies can be simple, like always explore with a 20% chance, or complex, involving sophisticated mathematical models. Remember, the goal is for the agent to learn the best policy, the one that will yield the highest reward over time. This often involves trial and error, making mistakes, learning from them, and gradually improving. Finding this balance between exploration and exploitation is a fundamental challenge in reinforcement learning. It's a beautiful problem to solve, one that mirrors many of the decisions we make in our own lives. So, in a way, reinforcement learning is not just about training machines. It's also a study of decision-making itself. So, where can we see reinforcement learning in action in our everyday lives? Let's start with self-driving cars. These vehicles are equipped with sensors and algorithms that continuously collect data about the environment. Reinforcement learning algorithms are at the heart of these systems, allowing the car to learn from its experiences. For example, if a self-driving car gets too close to a pedestrian, it might receive a negative reward, encouraging it to keep a safer distance in the future. Over time, the car learns to navigate the roads with increasing efficiency and safety. Next, consider video games. Reinforcement learning has been used to train artificial intelligence to play and master complex games. From chess to Dota 2, these algorithms learn by playing thousands of games, refining their strategies with each victory and defeat. The AI doesn't start with any prior knowledge about the game. It learns purely from trial and error, gradually discovering which actions lead to success. Now let's look at robotics. Robots can use reinforcement learning to acquire skills that are difficult to program directly. For instance, a robot might learn to pick up a delicate object without crushing it, or navigate a cluttered room without bumping into obstacles. And, just like with self-driving cars and video games, the robot learns these skills through a process of trial and error, constantly adjusting its actions based on feedback from the environment. Finally, reinforcement learning also plays a significant role in the world of finance, particularly in algorithmic trading. Trading algorithms can use reinforcement learning to optimize their strategies, deciding when to buy or sell based on historical market data. These algorithms learn from their past trades, adjusting their strategies to maximize profits and minimize losses. As you can see, reinforcement learning has a broad range of applications, many of which we interact with on a daily basis. What does the future hold for reinforcement learning? This question invites us to gaze into the horizon of possibilities, to imagine a world where artificial intelligence is not just a tool, but a partner in our quest for knowledge and progress. At present, reinforcement learning stands as one of the most promising fields in artificial intelligence. However, like any journey of discovery, it's not without its challenges. One of the most significant hurdles is the need for large amounts of data and computation. To learn effectively, reinforcement learning systems must interact with their environment millions, if not billions, of times. This demands a level of computational power and data accessibility that is currently beyond our reach. Moreover, the design of good reward functions presents another complex puzzle. How do we create a system that can not only learn from its actions, but also discern which actions are truly beneficial in the long run? This question isn't just about technology. It's about philosophy, ethics, and the very nature of intelligence itself. Yet despite these challenges, the potential of reinforcement learning is immense. Imagine intelligent systems capable of mastering complex tasks without prior knowledge, learning from their mistakes, and continually improving their performance. This is what reinforcement learning promises, and it's why researchers and innovators around the world are working tirelessly to overcome these obstacles. From healthcare to transportation, from finance to environmental conservation, reinforcement learning could revolutionize how we solve complex problems. It could enable us to develop more efficient algorithms, build smarter robots, and even unlock the secrets of human cognition. The journey ahead may be long and fraught with challenges, but the destination is worth the effort. As we stand on the brink of a new era in artificial intelligence, the potential of reinforcement learning is only beginning to be realized. As we continue to refine and advance these techniques, the potential of reinforcement learning in shaping the future of artificial intelligence is limitless. So, let's embark on this journey together, exploring, learning, and pushing the boundaries of what's possible.